Hello everyone, a very good evening to everyone, and I welcome everyone to the day two of TFUG India Summit, which we will be discussing on TF Lite and TF Mobile, right? And I am Navneet Malingan. I'm a software engineer and the lead organizer for Tensorflow User Group Coimbatore, along with my three in Surya, right? I'll be your host for today. So before getting onto the session, I just wanted to tell about the COVID-19 situation we are facing now. Okay, please take care of yourself, be responsible, wear masks, and maintain social distance. Um, we will get through out soon. Hope we have to flatten the curve before we get the vaccine, right? So take care of yourself. Without any delay, we will move on to the slides, right? So I will start by introducing about the TensorFlow user group communities, right? So this TFUG India Summit is organized by 13 TFUGs from India, and about the communities, in TensorFlow, we have four types of communities, right? The one is TensorFlow user groups and the Google developer experts, which we call as MLGDE, and special interest groups, SAGs, and ML working groups, right? So TensorFlow user groups are the communities of users. We have developers, engineers, data scientists, etc., who are passionate about TensorFlow and machine learning. So the aim is to build a global network of machine learning and TensorFlow enthusiasts to discuss on the latest technologies on TensorFlow and machine learning in general, right? And next is MLGDE. MLGDE are experts. They are not the Google developers, but they are working closely with Google developers to spread knowledge on machine learning and to help with Google Accelerator program and other TensorFlow related events. And third, we have special interest groups. SIGs are a group of contributors with a defined project focus. These groups take ownership of specific interest to add and maintain new features, right? So they work on cool things like IO, graphics, networking, JVM. So outsiders who contribute to the ecosystem, right? And fourth, we have ML working groups. ML working groups are a group of Googlers, and also we have MLGDs and TensorFlow organizers as well. So it's a great place to discuss and share about the new applications, new things, what we can build out of TensorFlow and showcase it to the community stuffs, right? So currently there are 5 ML working groups. One is MLOps, Mobile OS, JavaScript, Explainable AI, and Diversity and Inclusion. So what TensorFlow user group focuses on, right? So we focus on machine learning and TensorFlow in general. And as we know, TensorFlow is not anymore library. It's released as a library back in 2015. Now it has grown into a full-blown ecosystem. We have a lot of stuff in there, right? So TFUG focuses on spreading the knowledge about TensorFlow core products like TF the core library, TF.js, TF Lite, and TF extended. So we also discuss about the Tensor board and other plugins and support system what TensorFlow has to offer, right? And Google Cloud products related to TensorFlow and ML like Edge TPUs, Google TPUs, and Colab. And also machine learning concepts in general like privacy, bias, fairness, and NLP stuffs. So coming to TensorFlow user group India, so we have about 14 TensorFlow user groups in India, which is newly started back in Jan 2020, right? So we have been active for past 8 months. We have been doing a lot of physical events, like from Coimbatore, we had one physical event, but we have done a lot of online events. We missed those physical event. Like once the COVID situation is over, hope to meet you all in person, but currently we are active online. We are conducting workshops, hackathons, webinars, and some code projects online, right? So if you are very new to TensorFlow user group, so these are the cities we are active on. You can find your nearby cities and you can join anytime. We are on Meetup, and we are also active on Telegram and Facebook and other channels as well. But Meetup is our official channel, right? So you can go to tensorflow.org community/groups also. There you can find the worldwide communities of TensorFlow. So as I said, we are in about 75 groups, about in 15 countries, right? And the topic for today will be TensorFlow Lite, right? So yesterday we saw about TensorFlow Core, right? You have your data, you have your model, and you have trained it using your beefy cloud servers. But next is deployment, right? So we wanted to deploy it for the production use case. So deploying, you can deploy it either on the server or else you can deploy on edge devices, which is pretty close to the human or the person who's interacting with it, right? It has a lot of advantages. So the TensorFlow Lite is a tool provided by TensorFlow. It is a framework for deploying ML models on mobile devices and embedded systems, right? So you can deploy your models on iOS, Android, Linux systems like Raspberry Pis and Jetson platform, on Coral Linux platforms, and also ARM microcontrollers. So coming from an electronics background, it seems very exciting how these tiny chips can run neural networks and they can do wonders, right? So it's all we will going to learn about all these cool stuffs for today. And for the speaker lineup, so we have Khan, Naveen, Hiren, and Margaret for today. I thank you all these Googlers and outside speakers for accepting our invitation and presenting in our TFUG India Summit, right? And with that, thank you so much. And don't forget to submit your feedbacks. We will be sharing the link at the end of the session. So you can, once you submit the feedback, you will get the cool certificate for yourself with your name on it and the TensorFlow India Summit logo on it. You can share it on Twitter and with in your social media post. And be sure to tweet it. Yesterday we had a lot of fun online with the speakers. So please use TFUG India Summit hashtag, right? And tag your favorite speakers, tag in TensorFlow User Group India and the official channel as well. And we can have a lot of fun over there as well. And with that, over to Maitriyan. He will be introducing the speaker for today.
Hi everyone, welcome to the day 2 of our summit, and I hope you had a wonderful time in yesterday's session. And today's session would be equally fun one. So hope you have a very clear understanding about the TensorFlow community from the Navaneet speech, and we want all of you to join our community and spread the ML that we are growing. And today's session, we have our first speaker who is Khan. So if you are a mobile developer, you would be already knowing his name as he is quite a wide known speaker and is delivered in many conferences. Khan is a developer advocate at Google, working on Edge AI, on device machine learning, and on TensorFlow Lite. He publishes a lot of code on GitHub and also writes. Okay, so Khan, before getting into Google, he was a mobile developer for both Android and iOS. So he will be a perfect person to elaborate on how you can get started in machine learning on mobile devices and other lightweight devices. So here we go to the Khan's speech.
Hi everyone, and welcome to the TensorFlow for Mobile Day at the TensorFlow User Group India Summit 2020. My name is Khánh, and I'm a developer advocate at Google. And today, I'd like to kick off the TensorFlow for Mobile Day with an introduction to machine learning for mobile developers. So, many of you may have had an impression that machine learning models runs on the server side with large TPU, large GPU. But the fact is that edge devices, including mobile devices, has become a very important platform for machine learning so far. And why it is important to run machine learning models on edge devices? So the first reason is latency. And there are many use cases that require real-time processing of images, for example, and those use cases must run on the device to achieve real-time performance. And the second reason is offline availability, so that you can use the machine learning features even when there's no internet connection. And the third reason is to protect user privacy, because you don't need to send sensitive user data to the server for processing. And by being able to run machine learning models on edge devices, there are so many new features has become possible. And let me show you some examples of them. The first one I'd like to show you is a features in YouTube that allows users to try different type of lipstick. And you can see that this model, it uses real-time face landmark detection, and it detects users' lips in real time, and then use AR to apply different lipstick color to the user's lips. And the second example I'd like to show you for on-device machine learning is Google Translate, that allows you to capture text with your phone camera, and it can translate the text in real time without any internet connection. And TensorFlow Lite is a framework that allows you to build machine learning use cases on edge devices, on mobile devices. TensorFlow Lite is a framework that can run TensorFlow model on edge devices. And one of the huge advantage of using TensorFlow Lite is that you can use the same model to run on multiple environments, including iOS, Android, Linux-based IoT devices, microcontrollers, and so on. And you as a developers, you don't need to handcraft your model to optimize it for multiple different platforms. So currently, TensorFlow Lite supports 3 platforms. The first one is Android and iOS smartphones. The second one is the Linux-based IoT devices like Raspberry Pi or the Coral dashboard and so on. And the third platform is microcontrollers. So let me show you more details about TensorFlow on each platform. So let's talk about like iOS and Android smartphones. And this is probably the most popular platform for on-device machine learning at this moment. And we have more than 1,000 production apps globally that is using TensorFlow Lite in production, including many of the Google major apps like Google Photos, YouTube, or Google Assistant. And besides the Google apps, there are also many third-party apps that are using TF Lite like Uber, Airbnb, Hike, and so on. We saw that many developers are using TensorFlow Lite for use cases around image, text, and speech. But we're also seeing a lot of new and emerging use cases around audio and content generation. And besides mobile, TensorFlow Lite can also run on IoT devices such as the Linux-based IoT board like Raspberry Pi. And let me show you a couple of examples of how it is used in production. So Ecovacs is a vacuum robot manufacturer based in China, and they are using a object detection model running on TensorFlow Lite in their vacuum cleaner robot to detect obstacle and to avoid obstacles more effectively. And Accenture is a computer vision model running on an IoT device to measure worker activity on each workstation in a production line. So besides TensorFlow Lite, Google also has a hardware accelerator called Coral that can make TensorFlow Lite model run faster on edge devices, including smartphone and IoT devices. And Coral comes in several different forms, like the prototyping development board or a USB oscillator that you can plug in to a computer or a IoT devices via the USB port and run your model faster. In the next session, my colleague, will give you an in-depth introduction about Coral, so stay tuned to learn more about it. Then the final platform that TensorFlow Lite is currently supporting is the microcontroller such as Arduino. So what are microcontrollers and how they are different from the IoT boards that I showed you earlier that run on Linux? Microcontrollers are small and low power all-in-one computers that power like everyday devices around us, like microwaves, smoke detectors, toys, and sensors. And they are even smaller and run on lower power compared to the IoT board that runs on Linux, and they are also much cheaper, and it can cost as little as like 10 cents per devices. And with TensorFlow Lite, it is now possible to run machine learning models on those microcontrollers. You may not realize that embedded machine learning on microcontroller is already used in devices that you use every day. So for example, the hot rod detection, the OK Google detection on many smartphones now typically runs on a small DSP, which will then wake up the rest of the phone when it detects hot words. And the easiest way to get started with machine learning on microcontrollers is to use a Arduino device, and you can create your machine learning models using TensorFlow Lite and upload it to your board using the Arduino IDE in just less than 5 minutes. So that was it. That was a very quick introduction about what TensorFlow Lite is and what you can do with TensorFlow Lite. Then next, let me show you a complete example of how you train a TensorFlow Lite model and deploy it on a real device. We'll start with a hello world example of on-device machine learning. We will build an image classification model that can run on Android apps. So in this case, we'll use a flower dataset, which contains 5 different types of flowers: daisy, rose, sunflower, and so on. And then we'll train a flower classifier. Then we'll deploy it to an Android app so that your app will be able to recognize the flowers that you're pointing it at. So basically, there are 2 steps to build an app with TensorFlow Lite. First, we'll use TensorFlow Lite Model Maker, which is a library that allows you to train TensorFlow Lite model on your own dataset. You can train a model with just 4 lines of code. It will start by specifying your dataset. In this case, we'll use a flower photos that will store the training images in a folder called flower photos. And then it will choose the model architecture, the model specifications that you want to use to create your model. And in this case, we'll use the default model, which is a state-of-the-art FGNet Lite model. And then after we train the model, we'll evaluate it and then export it as a TensorFlow Lite format to deploy to our app. In on-device machine learning, you'll have to constantly make a trade-off between model accuracy versus inference speed and model size. So that's why we want you to be able to not only customize state-of-the-art model for your dataset, but also easily switch between different model architectures so that you can find the optimal balance between model accuracy and inference speed. And as I show in the code just here, you can switch between a ResNet model architecture to an FGNet Lite model architecture by just changing 1 parameter. Currently, we support image classification, text classification, and Q&A with TensorFlow Lite Model Maker, and new use cases such as object detection are coming soon. And then after you have trained your model, you can import your model to an Android app with just a few clicks using our Android Studio plugin. What you will do is that you select the model, TensorFlow Lite model that you want to import to your Android apps, and then it will just generate a interface for your model, and you can integrate a TensorFlow Lite model into your app with just like a few lines of code. Here you can see that we can just first initialize the model, and then take a bitmap that is the input for the model and convert it to the model input format, and then it will just run the model using just one line of code. Then finally take out the output of the model, which is a list of probabilities that represent which class the model, which type of flowers is showed in the image. So that was how you train a model, and let me show you how it is with a real demo. So here is I will use Google Colab and show you first how to train a flower classifier using TensorFlow Lite Model Maker. We'll start with install Model Maker using pip, and then import some necessary classes that will require to run Model Maker, and we'll download the flower training dataset from TensorFlow to the Colab machine. And then we start training the model. Sorry, we start by splitting our training data set into train data and test data, and we'll use 90% of our data set as training data. And then we train our TensorFlow Lite model to classify flowers using just like one line of code. And you can see that under the hood, this is like a Keras model. And after like 5 epochs, we are able to achieve 92% of accuracy. And then we evaluate our model using the test data, which is the remaining 10% of our data set. And we can see that our model didn't overfit. The accuracy is quite good, 93%. And then as a final step, we export our model as a TensorFlow Lite format. And finally, we download it to our local computer so that we can integrate that into our Android app. So here's the models that I already download to my local computer. And next, I will rename the model file to something that is easier to remember, flower classifier. Okay, and I'll go to Android Studio and import my model. Just right-click on my package, go and import a TensorFlow Lite model. Choose my model location, which is, and next I will import my model. And just click finish. Now you can see that Android Studio will automatically generate a model interface for me, and I will just need to copy this over to my Android app to integrate it into an existing Android app. And that's it. And you can see that how easy it is to train a TensorFlow model and integrate that into an existing Android app. So let's get back to the slide. So the flows that I just show you is also available as a code lab that you can go one step each and follow in details how to train a TensorFlow Lite model and integrate that into an Android app. Check it out in this link. So if you don't have your own dataset to train a TensorFlow Lite model, you can still download a pre-trained TensorFlow Lite model for many different use cases. There are three major places where you can find TensorFlow Lite pre-trained models. The first one is on the TensorFlow Lite website. We publish around 10 models there with Android, iOS samples that show you how to use the model. And you can just clone the examples from GitHub to try out the pre-trained model and use the code in the sample app to integrate the model into your own apps. The second place to find TensorFlow Lite model is on TensorFlow Hub. So TensorFlow Hub, as you all know, is a repository for TensorFlow models, and it has a session dedicated to TF Lite where you can download many TensorFlow Lite pre-trained models from there. And another place to find TensorFlow Lite model is on a GitHub repository called Awesome TF Lite. This is a community-run repository that collects TensorFlow Lite materials, not just limited to pre-trained models, but also sample apps, tutorials, and so on. So that was the very basic flow of how to train a TensorFlow Lite model and deploy it to a mobile app. And next, let me show you some techniques that it used to optimize TensorFlow model when you deploy it on edge devices. First of all, why do we need optimization? There are several reasons. The first one is devices such as smartphone have very limited CPU capability compared to a full-scale computer, and also has less memory. So we need to optimize your model to run better on those devices with limited capabilities. And unlike servers, many of the edge devices are powered by battery. So it's very important to reduce the power consumption and make your battery life last longer for your users. And model size is also very important. Given that the average size of mobile apps is around like 20 megabytes, if you integrate a 100 megabyte model into an mobile app, then that's definitely too large to be feasible in practice. So we need to optimize our model when deploying on edge devices. And there are 4 optimization methods that you should consider when using on-device TensorFlow Lite model. The first one is that to use a optimized model architecture for mobile. The second one is to make sure to apply quantization. The third one is pruning. And the fourth one is to make sure that you leverage hardware accelerator. So first of all, it's very important to choose a suitable architecture for on-device machine learning. For example, I think many of you may have been familiar with Inception and ResNet for image classification. But if you want to create a image classification model that runs on mobile devices, then you definitely should use MobileNet instead of Inception, for example. MobileNet V1 is slightly less accurate than Inception V3, but the inference speed is 15 times faster, and the model size is 9.3 times smaller. So it's more suitable for those edge deployment. And model accuracy versus model size and speed is always a trade-off that you need to make. In order to improve accuracy, the model size will need to be bigger and it will take longer to run. So it's very important that you find the right balance between model accuracy and inference size and model size and inference speed that is most suitable for your use cases. The good news is that there are a lot of new research papers that are coming out pushing the limits of on-device models. For example, the NASNet mobile or the EfficientNet model that came out last year, they use neural architecture search to automatically find the optimal model architecture for different deployment configuration, so that it will get a model that is smaller but still achieving very good accuracy. And there are many papers that came out of Google, like EfficientNet, that will comes with a TensorFlow implementation. And the good news is that we have integrated many of those latest model, state-of-the-art model into TensorFlow Lite model maker, so that you can train, you can customize those state-of-the-art model for your use cases with just like a few lines of code, like I showed you earlier. The second optimization method that you need to consider is quantization. And when you build and train a model, it probably use 32-bit float to store the weight. However, when running inference, it turns out that even if we approximate the 32-bit float into a 8-bit integer, the model doesn't lose much accuracy. And the benefit is that the quantized model becomes 4 times smaller than the original float model, which makes it much easier to deploy on mobile devices. TensorFlow Lite model maker supports quantization, so you can apply quantization to your model without much effort. And here's the accuracy number comparing the quantized version of some popular models. And you can see that with quantization, the accuracy drop is quite acceptable. The third optimization method is pruning, which shrinks the model size by making some of the model weights to become 0. And a prune model can be compressed better because it has many 0. And having a lot of 0 weights also reduce the amount of computation needed to run the model, making the model inference faster. And here's a benchmark of a prune model. And you can see that by reducing the number of non-zero weights in the model by half, the model accuracy is still pretty good. And the good news is that pruning can be combined with quantization, which make your models even smaller without much drop in accuracy. And then the last optimization technique is to make sure that you use a hardware accelerator when running model inference. So you can see that by applying quantization, the model inference is already like faster, like 3 times faster. But if compared to using a float model on running on the same CPU, but if you use a hardware accelerator like CPU, which is available on many mobile devices, it will even be able to achieve a faster inference. And for the chip that is dedicated to running machine learning model like the edge TPU or the Coral chip, it will even get even more, even better performance. So that's it. I've shown you how to build a TensorFlow Lite model, how to deploy it, and several techniques that is to optimize your model for edge deployment. And in the last section of today, I'll show you several other tools besides TF Lite that have you use machine learning on mobile. And let me quickly introduce you to 2 of the tools that is created by Google, MLKit and Google Cloud AutoML. So MLKit is a ready-made library that allows mobile developers to run machine learning models, to use machine learning on mobile devices without any machine learning expertise required. And you can use it like any mobile SDK. It is built on top of TensorFlow Lite, and because of that, it can run on multiple platforms, including Android and iOS. So MLKits is a library that provides many pre-trained models through an easy-to-use API that span across multiple popular on-device machine learning use cases, such as recognizing text or detecting face or on-device translation and so on. And let me show you a quick example of the API of MLKit and how it is used in a mobile apps. We'll use an example of an object detection and tracking API. And you can see that the model is capable of recognizing an object in an image and returning the bounding box that show you where the object is. And you can see here's the code to use the MLKit API for object detection. It will start with initializing the object detector, and then you create a image that you feed the image that you want to detect object from it, and then just runs a object detector, and as a result, it will get back the bounding box on where the objects are in the image and a category of what the object is. Very simple, isn't it? And by combining the object detection model, the MLKit object detectors, with a cloud API such as Cloud Vision Product Search, you can do things like allowing users to search for products with the smartphone camera. And you can see that the users can point at the flower pot here, and then sends an image that it detects to the cloud, and then the cloud will return the price of the items that it found, similar to the image that it received. And besides MLKit, Google Cloud also provides a tools called AutoML Vision Edge that helps you to create on-device machine learning TensorFlow Lite model with just a few steps. In order to build a image classification model with Google Cloud AutoML on your own dataset, what you need to do is just to prepare your training data, train the model on the cloud, and deploy it. So here's how it works in practice. You first will just need to use the Google Cloud GUI tool without writing a single line of code. You start by preparing your training data and then upload it to the Cloud Console. And then you train your model with just like a few clicks, choosing that you want to train a model for offline and mobile use cases. And you can choose the trade-off that you want, whether you want a higher accuracy model, which is also runs a little bit slower, or you choose a fast model, which is very small, but will have a little bit low accuracy. And then once you have finished training your model, you can download a TensorFlow Lite model and then integrate that into a mobile app. For example, an Android app using the same Android Studio import model flow, just like I showed you earlier. Currently, Cloud AutoML support two image use cases for edge deployment. One is image classification that I just showed you earlier, and the other one is object detection. So that was it. I hope that through this session, you have seen how you can quickly deploy a TensorFlow Lite model into your mobile app and start using machine learning on mobile. Thank you for your attention.
Thanks a lot for the great session, Khan. I hope the participants would have learned a lot about the world of edge AI, from deploying it and also about the optimization of these various models. I know that I can see many curious people who are asking interesting questions in the comment section. So we have two of our experts from our team who can clarify the doubts that you have. We have Sayak Paul, who's a GD in ML, and we also have Navneet, who's the head of Coimbatore AI. So here we go. You can shoot your questions to them.
Hi,
Yeah,
Sayak.
yeah. Navneet, would you like to take a few
Hi.
questions that you already observed?
Yeah, sure. We can bring out the questions and hope you can start. You have been working on the ML AI space for HI space for quite some time.
Yeah,
So
I actually beforehand observed a couple of questions that I wanted to answer. The first one I saw is, when using TensorFlow Lite APIs, will there be any significant drop in performance? So my advice would be, depends. It's absolutely possible to export pretty world-class models without having to compensate on the accuracy part when you are working with TensorFlow Lite APIs, but that might not be applicable in some cases. But for most of the cases, you should be able to export a model that is both that is both lightweight and performant enough to get you your desired accuracy score. The second question that I observed is it possible to use TensorFlow Lite APIs with noisy student training or techniques like distillation? Again, the answer is yes. It's absolutely possible to use TensorFlow Lite APIs on a distilled model. So the idea would be to first do the traditional knowledge distillation process to build out your smaller model, and then use TensorFlow Lite APIs in order to further reduce its size. So yeah. So Navneet, it's over to you. If you have any specific questions to answer in your mind, then we can take them.
yeah, not really. I've been working on the embedded space for quite some time. I just wanted to share a few thoughts on that, right? Especially before that, I'm an electronics engineer, primarily working on IoT space, right? I'm not into Android and iOS anyway, but I'm into microcontrollers and Raspberry Pis and stuff. Right? So when it comes to IoT, we have a lot of problems where we are facing, right? Mainly the latency problem. So especially if you're using some bandwidth constraint networks like Bluetooth or LoRaWAN, something like that, you will have a bandwidth constraint where you cannot export all the sensor data to the server and do some insights over there and actuate again back to the board, right? So whole lot of edge inferencing will make a lot of sense. So let's say an industry use case where you have a vibration sensors and flow sensors, and you wanted to find some anomaly, right? If a machine vibrates in a different pattern, you can find out whether it is going to break down or it's not going to break down, right? So especially it can be used in motors, like maybe engine motors, to find the vibration pattern. It can be used in buildings to find the structural vibration stuff. There are a lot of use cases for that, like especially if you are deploying in some kind of forest. Okay, you can identify what bird sound. From the sound itself we can do the edge inferencing, right? So TensorFlow Lite, they also offers TensorFlow Lite microcontroller interpreter, where you can export your models and convert into the binaries. Mostly it's Xcode, right? So after that you can run it on a microcontroller. You can do it on Arduino based microcontrollers, you can use it on ESPs, okay, and also you can do it on ARM based STM boards, right? So it's not limited to any kind of such platform. You can deploy it anywhere and make your edge AI pretty cool. Okay, so that's what I had to share. And Sayak, we have a next question. Is there any trade-off between pruning and prediction accuracy in the context of sparse TF models? You want to answer?
Uh, yeah, sure. So if I'm understanding your question currently, Raja, are you asking, when using pruning APIs or pruning in general to deep learning models, does it affect the accuracy score? If that's the question, pruning does not really affect the accuracy score that much. At least in my experience, we have a lot of empirical evidence that suggests that pruning does not anyway make your models less performant. And I would definitely recommend checking out the paper on lottery ticket hypothesis, which kind of dives deep into the space of pruning. Recently, the folks at Hugging Face proposed something called movement pruning, which is based on fusing pruning into your pre-trained heavy networks. So yeah, I mean, pruning in almost all of the cases won't affect your prediction accuracy that much. So, yeah. I have another question. Okay. Is TensorFlow applicable in cybersecurity field? Is there any security companies that are there any security companies that use TensorFlow? Yeah, I mean, I myself have used uh, machine learning specifically, not TensorFlow, in the cybersecurity space. When I during my stint at TCS Research and Innovation, we were heavily into fusing cybersecurity and machine learning and stuff like that. So yeah, it's absolutely possible and it's being practiced currently. But I'm not sure whether about the cybersecurity companies that use TensorFlow. Yeah, I think we have our next speaker. So that's it for the questions. Sorry to disappoint you folks. So I'm gonna see myself out, and
Yeah, so the next speaker is Naveen, and over through Maitrian, he will be introducing the speaker for today.
Hi, we are very happy to introduce Naveen, our next speaker. He's an application engineer at Google, and he builds transfer learning pipelines, optimizes models, and works in low-power devices. His goal is to make Coral ecosystem to power the wide space of the world. So here we go. Here to you, Naveen.
Hello guys, welcome and namaste. Thank you all for having me here. Firstly, I would like to thank TFUG organizers and attenders for making this event happen. So I would like to introduce you guys Coral, an ecosystem for on-device inferencing. Let me present my screen. So Coral is an ecosystem for on-device inferencing, and today I'll be walking you guys through all the platform and introduce you all the hardware and software tools available in the Coral. So what is Coral? Coral is an platform that helps users to develop and deploy AI application to run on-premises inference, which enables users to have a great amount of privacy. And it also accelerates machine learning operations, helping users to run state-of-the-art models at real-time speeds. Since everything is on-premises and on-device, you can completely deploy your application on offline and also efficiently use your network data. And Coral devices are very low power, so you can build most of your embedded applications at a very low power applications. So what Coral devices consists of? So Coral devices consist of edge TPUs, which are developed and released by Google. So each edge TPU is able to deliver up to 4 TOPS of performance, consuming 2 watts at the peak. And all the edge TPUs support a fully quantized version of TensorFlow Lite models. And just to mention, by the way, if you guys cannot hear me, please feel free to let me know about it. So when I'm introducing Coral platform, it consists of 2 components. One is the hardware components and the software components. Under hardware components, we have solderable modules, accessory boards, and environmental sensors. Under software components, we have OS runtime and a compiler for exporting machine learning models to HTPUs, and lots of documentation for you guys for the reference. Yeah, these are the Coral products. Here, a dev board is a system on module, which is similar to a Raspberry Pi, but it has an edge TPU integrated on top of it. So, and a USB accelerator, which can be plugged into a host machine to run on-premises inferences. Both dev board and USB accelerators are by far one prototyping devices. But if you're done with prototyping your application on Coral, and if you decide to go into production, we have a system on module where you can design your own baseboard and a PCIe accelerator or a M.2 form factor, which consists of HDPU and can be plugged into your own CPUs. Coming soon, we have a mini version of the dev board that you guys seen in the previous slide. So this is a much more low power, and it consists of the same HDPU as well, and same system on module base chip with a higher memory, 2 gigs and 4 gigs, and an accelerator module which can be soldered down into as a PCIe or a USB connection. So these are all our hardware products. So basically everything is a HDPU in various form factors. So let me introduce our software platform. Under software platform, we have developed and released a OS called Mental OS, which is an operating system for both DevBoard and the DevBoard Mini that you guys seen. Under community spread, we have Yocto for people who are interested to build their own baseboard, and you can build integrate edge TPUs into your own applications. And when it comes to runtime, all the Coral devices are supported on Linux. Under Windows, we only support USB accelerator and a PCIe. And under Mac, we support USB only, but you can also connect your dev board via SSHing using a Mac. So most of the packages are supported by the Debian. So when it comes to interpreter, we totally depend on TF Lite interpreter, which is available through pip wheel packages. So Coral devices support a TF Lite models. So when we are talking about on-device inferencing, everyone has a question about where I can ship my models from. For that, we have a couple of different spaces. One, we readily have pre-compiled models at coral.ai/models, which you can directly deploy on the dev board or a USB accelerator, or you can apply some transfer learning, for which we have a couple of tutorials, and or use AutoML in the GCP cloud to train your model and deploy, and use a compiler to deploying onto the Coral board. And the best option you always have, you can always build your models in TensorFlow, train them and compile your own model using Coral compiler and deploying auto HTTP. Yeah. So under most of our software is located in coral.ai. So you can refer to coral.ai for the software and go on to the models/AI or docs page to understand more our documentation. And you can find more demos and the example codes there as well. But in the next coming pages, I'll introduce you where you can find the demos and examples more clearly. So these are our benchmarks on generated by running inference on edge TPU. So you can see the state-of-the-art model like MobileNet V2. We are able to run at at a latency of 2.5 milliseconds, and Inception V2 or Inception V4, we are able to run at a latency of 100 milliseconds. So one of the more common applications on Coral are observing the population flow by providing privacy on the street cameras. So as you can see here, you're understanding the number of people going in a frame, but you're not taking any of their personal data, or you're not identifying a person as itself. You're just getting the metrics as number of person instead of who is actually in the camera. And also you can estimate population density in a cafe to understand, to alert employees or the users about the crowdedness of the cafe. And this can be, since everything is on device and on premises, it can be a very low powered application and sustainable without having internet connections. Another application is traffic flow, where under the transportation vertical, you can estimate the number of cars right now, but technically this model can be exchanged with any other model, and you can find your own metrics like identifying a specific car or identifying just number of trucks and all. So for the COVID-19 mitigation, recently we have seen a couple of community projects that have shown up on the Coral platform. One among them is a neural net application, which estimates a social distancing metric among the street cameras. And another one is the face mask detection, which detects whether a person is using a face mask or not. So when you think of on-device premises, it's nothing like you cannot connect to the cloud, but Coral devices or a Coral dev port can always be connected to the cloud under very limited connectivity. You can also push very important data metrics. So using IoT Core, you can develop a hybrid solution where you can run the inference on device and send the metrics back to the cloud. This saves a great amount of bandwidth that you communicate to and from the cloud, and also save a lot of time because you're not sending any data to the cloud and waiting for the results. So we have seen many hybrid solutions that our users have developed where they used DevPort to run on-device inference and share back the metrics back to the cloud. So for this, you can use Cloud IoT Core, and we also have tutorials for which you can develop your own application using Cloud IoT Core. And when you're considering cloud tools which can be used in the Coral platform, AutoML is one of the other cloud tool where you can export your data and train the model, and you can directly deploy your model onto the DevBot. So here Google-Coral is our GitHub handle, where you can, if you're interested to start your own projects or develop your own applications, you can find some great examples which can be as a starting point or a reference for your development. And recently we have released a project, Banana Robo, which uses a Raspberry Pi and a USB accelerator to detect if there is a banana in the stream and follow the banana. But the main goal of the example is to emphasize use of a Raspberry Pi and a USB accelerator. And the other demo is called the body pics that you are seeing here, which anonymizes the population and allows you to get the metrics like pose detection and human segmentation. But if you're looking to develop your own applications, Google Coral GitHub handle would be a good place to start. And I encourage everyone to take a look at this GitHub handle to look at more applications of Coral. So when you're thinking about developing your own model, this is how the workflow looks like. So first, you would develop a model in TensorFlow and train it, and then use either quantization-aware training or then you export your model into a frozen graph. So every model has to be full integer quantized in order to be supported by edge TPUs. So for which you have two different paths. One, you can either train during one you can quantize during the training, which is quantization aware training, or you can perform the quantization after you train the models, which is post training quantization. Both TF Lite has a conversion APIs, so for which you can, which would help you to quantize a model and export a TF Lite model. So once you have the model.tf Lite, the next step is straightforward. So you just pass through the HTPU compiler, Coral compiler, and deploy it onto HTPU. And we use the same interpreter as a TF Lite. So running an inference script or from the model is similar to what you do in a TF Lite script, except for loading the tailgates of HTPU. So once you compile a typical model onto HTPU, this is how it looks like when you open a Neutron. So as you can see, all the operations in the middle of input and output are mapped to HTPU. So this clearly shows us that the input and the output operations are offloaded to CPU. So these operations happen on CPU, and only the critical operation, all the rest of the operations are mapped to HTPU, and it accelerates the AI operations. So HTPUs are used to accelerate all the machine learning ops, but all the input and output operations or the post-processing operations are offloaded to CPU or GPU. So there is one thing to remember, that HTPUs will not accelerate all the operations. It only accelerates the custom operations on which are involved, which are inside the model. So yeah, if you guys are excited about Coral and want to order it from India, I've seen different links, but Gravity Link Store is officially supported by Google. So you can order at Gravity Link Store. I think currently they are on sale as well. So yeah, you can order it directly to India from the Gravity Link Store. I've seen a couple of third-party sellers as well, but we are not sure who the sellers are. So Gravity Link could be a good spot for you guys if you want to order some Coral products. So finally, if you guys more questions or if you guys need any help, you can log on to coral.ai/support. If you have questions, you can post it on Stack Overflow. If you have bugs, you can report on Google Coral GitHub handle. And more than everything, if you have more technical questions, or if you need more help, you can always send an email to coral-support@google.com. But coral.ai/support would be a good stop for you if you need any help over there, and where we also release our news about the new compilers and the new software updates. Yeah, with this, I would like to end this presentation and open this session for the questions. But thank you again, and dhanyavad. So I'm happy to be here. Thank you, organizers and the attendees. Thank you so much.
Hi, Naveen. Navneet here. Hi. That was a wonderful presentation. I myself pretty excited to try all these things for myself. And we have a lot of questions from the chat box.
Sure.
Once it pops up, you can take few questions. And I myself have a personal question. Can we use Coral chip and Coral board for production level applications? Is it okay to do that? Or else it's just dev board?
No, so you can. We have seen customers using Coral dev boards for production level applications. So, and we have a system on module as well, which you can uh, take into production level application and build your own baseboard if your application requires a custom built baseboard. But as you have seen, a dev board is very open-ended, so it requires some environmental shielding if your application is deployed externally. But it can be a production level device.
Okay. Thank you, Naveen. And we have next question from Aishwarya Velumani. So we are planning to make a project using both AI and AR. So the AR part as made with Unity, AR Foundation, and in Android. So what type of TensorFlow would be best for this?
I'm not sure if this is Coral specific, but currently Coral devices only support a TF Lite version of the models. So I would suggest a TensorFlow Lite version, which is fully quantized. What is quantization? So usually a TensorFlow model, the data type in that is float 32. But TensorFlow Lite helps you to quantize the model and change the data type to float 16 or in 8-bit integer, which can be very efficient and on a low-powered hardware device. So currently, Coral devices support 8-bit integer quantized models, for which TF Lite will help you to calibrate and quantize the model.
Yeah. So can Coral be used for text recognition for better accuracy like we have Tesseract, OCR by Pratibha?
Yes. It can be used for text recognition as well. So currently, Coral devices also support LSTM operations. So of course, it supports convolution. And as I have seen, most text recognition operations or the text recognition models consist CNN and LSTM lock at the end. Yes, we do support OCR.
Okay. Yeah. Is it possible to configure I/O ports in Coral like Raspberry Pi? From Paneer.
So Coral DevBoard is a Mandel OS, which is built of Linux Debian package. So it is possible to configure your I/O ports on the dev board.
So one personal question: does it have an GPIO pins like analog in and digital in, normal pins, pin headers?
Yes. It is. It has GPIO pins.
Okay, great. Do we have any more questions? What are some limitations of Coral by Vasudev Sharma?
What are some limitations? Yeah, so I would since it is a very low power and on-device AI accelerator, it only supports a subset of operations that are available in TensorFlow. So though we support the state-of-the-art models like ResNet, MobileNet V2, or InceptionNet, there are few other specific operations or special operations which we don't support. So it has to be TensorFlow op and supported by Coral to accelerate the process.
Okay.
So
great.
maybe that's a limitation for now.
Okay. And best advantages of Coral by Ismail Faris.
So yeah, so as I mentioned, as these days privacy is a main concern, you can run the complete AI applications on device and under very low power as an embedded. So you can literally use a power bank to run your application, run your AI application. But I've seen a lot of ResNet laptops cannot run a ResNet 50, but a small, very low power device like Coral can run a ResNet 50 easily without even consuming the peak power.
Yeah, great. That's all for the questions. Thank you, Naveen, for answering all the questions. And the session was very, very informative. As I said, I'm myself pretty excited to try all these things. And thank you for accepting our invitation and enlightening us with the Coral Dev platform. And thank you for your wonderful session.
Same. I'm glad to join you guys and share the knowledge. But thank you so much, and I'm glad to see you guys as well.
Yeah, thank you.
Yeah, thank you. Bye-bye.
So next we have a few posters from Manning. So you can get offers. You can buy books from Manning site, and you can get them for 35% discount, right? So Manning is one of our sponsors, and you can do your purchase over there, right? And with that, we will move on to the next speaker. Our next speaker is Hiren Dave. He's an author, blogger, speaker with more than 12 years of experience in industry, and he's also worked on various projects from web to mobile to cloud to AI and ML. So always eager to learn new technologies and share the knowledge of to the developer communities. And he's also co-organizer at GDG Ahmedabad and Laravel Live Ahmedabad. With that, over to you, Hiren.
Yes. Hey, hello everyone. Thank you for my introduction, Nate. And I welcome you all on this mega event, TensorFlow, which is organized by TensorFlow User Group. It's such a pleasure to be speaker over here. And so, yes, as my introduction is done, my name is Ren. I am the co-organizer of GDG Ahmedabad and Laravel Ahmedabad, and currently I'm working as a Chief Technology Officer, and I work on lots of technologies. Now let me share my screen so I can start my presentation. Can you include my screen, please? Yeah. Right. So this session is all about machine learning in browser with TensorFlow.js. This is kind of a session. This is a kind of a getting started session for the developers and for the front-end developers or for the JavaScript developers who are planning to get started with the machine learning in browser with TensorFlow.js or wanted to get introduction about TensorFlow.js. The brief agenda of the session is we will cover the basic terms of the TensorFlow.js, we will understand how it works, and we will see certain examples of certain machine learning applications implemented in TensorFlow.js. Right, so let's first understand what is machine learning. So this is for the this is a really very simple term. What is machine learning is that we have some data, we train the data. Not sure as of now we are not specifying that what kind of techniques we are applying for training the data, but yes, we are training the data and then we are making the predictions. Sometimes it happens that whenever your prediction is not accurate, we have to retrain the data. So this is a kind of an ongoing process when you are implementing any of the machine learning applications. The training should go for many steps till you have good accuracy in the prediction. And then once you have a good prediction, that's your end. So this is a very simple in layman terms. I'm explaining that what is the machine learning. Now, let's understand why we have to do ML in browser. Because normally what happened is that since machine learning and artificial intelligence and deep learning, a lot of things are in the market, most of the developers are trying to implement it. And as we all know that for machine learning, till now, we have been using a language called Python. There are lots of libraries available in the Python. In fact, TensorFlow has the libraries for the Python, and a lot of things you can do in the TensorFlow with the Python. But then, why we should do machine learning in browser? So let's first understand that. This is pretty simple stuff. You don't have to install any driver. You don't have to install any plugin. Simply just download the TensorFlow mini.js file in your application, and that's it. You are ready for implementing the machine learning. On the left-hand side, what I'm showing is that when you are implementing any Python application, you have to do this kind of stuff. You find out the Python version and install the pandas, Django, NumPy, Flask, TensorFlow, sklearn, and there are all lot of libraries available for the machine learning in the Python. When you are implementing any machine learning application in the Python, this is the step you have to do. But while you are implementing machine learning with the TensorFlow.js in the browser, all you need is a script tag where you have mentioned the TensorFlow.js minified file, and that's it. Once that file is downloaded, you can start implementing your machine learning applications, whether you're trying to create a model, whether you want to predict something, whether you want to preload some existing model, all you can do after your modified library is downloaded. So that's pretty much simple. So machine learning with the browser is highly interactive. TensorFlow.js has introduced something called interactive machine learning. So what is that interactive machine learning? The interactive machine learning is where your end user can interact with and can do some actions. When you are implementing machine learning in the Python, normally what my Python developers, I have seen a lot of my colleagues and my fellow developers doing ML applications, the Python, that they have a black and white terminal, and then they are the training model of doing something. This is what on the left-hand side, what is displayed is they are not going to be able to see that, step 1 is going on, step 2 is going on, what is lost, how much steps are completed, that's it. But when you are doing machine learning in the browser, because it's running in the browser, your end user can interact with a lot of things, like you have a fancy buttons, you have some web pages where you allow user to touch it, you allow user to click it, you allow user to stop it. So this is a new way of having the machine learning, which we call it as an interactive machine learning, which is very, very possible with TensorFlow.js because it's running, after all, it's running in the browser. Of course, when you are implementing machine learning in the browser and you are opening this particular application in the mobile app, you have access to all the sensors. So for example, GPS, microphone, camera, gyroscope. When you are doing this stuff in the mobile or in the desktop, you have access to all the sensors. So if you want to do or you want to implement any such application or any application which uses this kind of sensors, you can obviously use that. And that is only way possible when you are doing machine learning application in the JavaScript or in the web. So that's why it have an advantage that you have access to all the sensors. Machine learning application in the browser can work offline, and of course, it's a data privacy when your data is, because data is a new oil, as we all know that, and you want to protect your data at the time. machine learning in the browser can be very, very useful, because as we have seen that when you download your assets, all the required assets like TensorFlow, unified file, your script, all the things which are required, all the JavaScript libraries and all the JavaScript things which you need, once it is downloaded in the browser, it can run entirely in the browser in the offline mode. You don't need an online connection. So that's where you have an advantage, that when you are implementing machine learning with the browser, you can work offline and you can protect your data. And of course, web is everywhere, because JavaScript is supported in almost all the devices, whether it's a desktop, whether it's a clock, whether it's a smartphone, whether it's a smart watch, tablet, desktops, IoT devices, everywhere web is supported and everywhere JavaScript is supported. So while using a TensorFlow.js, your machine learning application has wide variety of platforms that can be supported. So that's one more added advantage of TensorFlow.js. Now let's understand what it offers. With the TensorFlow.js, what you can do is that you can create models directly in the browser. You can import pre-trained model for the inference, or you can retrain your imported models. When we say create, we'll see the example in some time. When we create a model directly in the browser, is that simple. It's like you just download the browser and you just open the browser, you just download the TensorFlow JavaScript and you define your model, you train your model, and at the same time, on the same front, you make a prediction after training the model. So that's why you can create a model right in the browser. TensorFlow.js, since it is introduced, there are a lot of developers who have created lots of interesting models like MobileNet or POSNet. There are so many inbuilt ready-made models available. We will see one of the example in the upcoming time, in very short period of time, where we are going to see machine learning application specifically for the text classification. We will see how you can import a pre-trained model for inference, and you can retrain the imported model. So this all capabilities you can gain from the TensorFlow.js. Now let's understand a bit about TensorFlow.js architecture. So this is how TensorFlow.js works. On top level, you have the layers API, which is supported by Keras model, or you can, which is supported. And at the bottom, you have the ops API, which we call as an operations API, that is supported by the TensorFlow served model. And then this operation API directly work with the browser. And TensorFlow.js also support WebGL. So if you want to do a GPU accelerations or GPU-based machine learning in the browser, you can get a use of WebGL, and through WebGL, you can implement or you can create a GPU-based machine learning applications in the TensorFlow.js. Okay, now let's see a quick example. So I'm just going to switch to my. Okay, so this is a very, very simple example of TensorFlow.js. As you can see over here that we have downloaded the TensorFlow.js 2.0 version from the library. Then what we are doing is that we are creating a tensor. We will see what is tensor. So this is my tensor 1, this is my tensor 2, and then I'm doing an operation that I'm adding a tensor A to tensor B, and then I'm multiplying tensor A with tensor B. So this is my definition of tensor, and this is my operations. So if you want to see an example, right. So here, if you see, we have print the operation, which is the add operation. So as you can see, what it does is that it added, so 100 plus 10, which is 110, 200 plus 20, which is 220, 300 plus 30 is 330, 400 plus 40, which is 440. So this is what we are doing over here, that what we have is we have defined the tensors and we have defined the operations. Now let's see again, let's go back to the slides. And let's understand the basic terms. So first basic term is tensor. So tensor, what is a tensor? Tensor, it is an n-dimensional array, and it's the main building block of TensorFlow. tensor, you can create an n-dimensional array. So here what we defined is what that was a single dimensional array. You can create a matrix. You can have 2-dimensional, 3-dimensional, n-dimensional array, which is the main as a tensor, which is your main building block. And each tensor has certain properties like rank, size, and data type. So rank defines what is the rank of the tensor. Size defines whether it's a 2-dimensional, 3-dimensional, n-dimensional. Data type is like whether it's storing the integer data, string data, any type of data. So this is how you can create a tensor. So this is a basic example of what we have seen in the code, that I am defining the tensor with the function tensor, and then I'm giving an n-dimensional array over here. Now let's understand what are the operations. It allows you to manipulate the data stored in the tensors, and you have wide variety of operations are available. So one operations we already seen, we have add and we have multiplication. Similarly, we have lots of operations using which you can manipulate the data stored in the tensors. Okay, now let's build a simple ML model. So I'm going to switch to my code again, and I'm going to show you a code, which is my very simple model. So what my model doing over here is that I have defined an equation that 1 nautical mile is equal to 1 kilometer multiplied by 1.852. This is my operation. This is my equation. Now what I'm doing is that when my TensorFlow.js library is downloaded, I am calling a run function on the DOM content loaded. So when this run function is invoked, first it is defining the equation, then it is defining two tensor, which is my x and y tensor.
Kiran, sorry to interrupt you here. Your screen is frozen. It's not updating with how you are proceeding ahead. So your screen needs to be reshared, I guess.
Okay. Yeah, can you put my screen back? Okay. Okay, now is it visible?
It's about to appear. It hasn't appeared yet.
Okay, let me stop sharing and share one more time. I will just share my prompt app. So that should be fixed the issue. Is it good now?
Yeah, it's good now.
Okay. Right, so I will show it over here itself, so we don't have any issues, right? Okay, so instead of going back to the code, I will show code here itself, right? So, okay, so here what we have done is that we have created one equation, right? And then we have defined one tensor xs and tensor ys. And then we are creating a sequential model, which is a very simple regression model. And then we are adding a layer to this particular model. And then we are defining a loss function and optimizer. We will see what is the loss function and optimizer. And then here what we are doing is that we are starting a training with 100 epochs. We will see what is epochs. So once my training is completed, it will console out my training completed, and it will show that we're making a prediction. And what I'm doing is that I'm making a prediction for 20 nautical miles, which should be connected to the number of kilometers. So if you see in the console log that the training was started, it got completed, and then it made a prediction that 20 nautical miles converted to Kimi, which is 38.26 kilometer. So in a basic term, what we have done is that we have created a very simple model over here. We defined a couple of tensors, we defined a layer, and then we trained the model for 100 epochs. And once my training is done, we made a prediction, right? So that's pretty simple stuff. Now let's go back to the presentation. Right. So this is what we have done. We have downloaded the TensorFlow.js library by implementing in the script. And now let's understand the basic term. So the first basic term what we have to understand is epoch. So when we have a huge data, we divide it into the batches of the training, and then we feed those batches one by one for the trainings. And when all batches are done, that's an epoch. So epoch is basically used for Epoch is basically used for converting your huge batch of data to small chunks and applying it to the and giving it for the training. So more epoch you give, more accuracy you may get. So here we have just given the 100 epochs for the training purpose. It depends on what kind of model you are having and what kind of machine learning applications you are implementing. It depends on that, and you can then go for the number of epochs, right? So and then what are the loss functions? So when you have huge data and when we are feeding data one by one to the training, how we can ensure that model output is correct? So that's where a loss function we are using. That loss function can decide that the trained output or the accuracy of model, if it is with the associated cost. If it is not good, you can go for further training and do more iterations. And if it is good, then you can stop it over there. So loss function is basically used for making a decision that whether you have done enough training or not. Okay, next example we will show using TensorFlow.js with Node.js, right? So what you can do is that for implementing a TensorFlow.js along with the Node.js, you can install this TF.js node package by npm install. And once it is installed, just like the JavaScript, you can create the model and everything over there in the TensorFlow.js, TensorFlow.js with TensorFlow.js and the Node.js. Now let's see a quick regression example. I'm not sure my screen will show, but let me just open that. Right. So here, I'm just opening my JS library over here, and what we are doing is that we are importing
When your
TensorFlow.
base terminal is not visible, you have basically just shared your slide screen. Probably your browser screen is not shared. So you might need to share your entire screen or something like that. And the entire time the code part was not visible at all.
Okay, sorry. Yeah, can you say it again? Yeah, can you put my screen back?
Yeah, I just put your screen back. We can see your screen now.
Can you add my screen to the presentation, please? Okay. Right. So, okay. So now I think it's visible. So this is a basic regression JS regression model. What we are doing is that we have created a regression function, and we are defining a couple of tensor with tensor 2D. So we are defining 2D tensors over here, and then we are creating a sequential model, and then we are creating or we are training the model on the 100 epochs, and then we are making the predictions. Because my terminal is not shared, so I cannot show the output, but then what it does is that for 100 epochs, it will train the model, and then it will make the predictions. Right. Now let's go back and okay. So if you want to use any Python model with TensorFlow.js, this is what you have to do. Once you save your Python model, you have to convert it with the converter available, and then you can load it in the TensorFlow.js. So using this, you don't have to recreate a model in the TensorFlow.js, which is already there in the Python. You can entirely reuse it. Okay, now let's see some of the example. One is the text classification for detecting the text toxicity. And for that, we are going to use a pre-built model. So let me just share that screen. And okay, as you can see over here, what we are doing over here is we have downloaded TensorFlow.js from the script, and then we are downloading a toxicity model, which is a pre-built model or pre-available model. And then what we are doing is in the script, once my toxicity model is loaded, this is my text, which is I'm going because I want to see or show you an example. And this is what you get an output that this sentence contains this kind of toxicity. It's an identity attack, it's an insult, it's an absence, and everything, right? So this is how you can preload your existing TensorFlow model. So this is a classic example of using a pre-trained model or pre-available model with the TensorFlow. So it's very simple. You just downloaded it, you set up some threshold, and then once it is loaded, you give your sentence, and then it is just using for the classifier, right? So this is how you can use inbuilt or existing model with the TensorFlow.js. Next is object detection, because my screen sharing has some issues, so I cannot show you the code, but this is what it can do. As you can see that what I have done in the application is that using a pre-built model, which is the ModelNet, and it has some object library and pre-built images available. What we are doing is that we are using the camera to capture the frame, and then what we are doing is that we are trying to detect what all objects are there in the frame. So here, as you can see that it is identifying me as a person, and I'm holding a cell phone in my hand. So it is identifying a cell phone as an another object, right? So this is how you can use TensorFlow.js for the object detections. I cannot show you the code right now, but just to as I mentioned in the example that here as well, I'm using the pre-built model. So what I have done is that I have downloaded the TensorFlow.js library, and then I have used the inbuilt model. And using that inbuilt model, we are trying to predict and we are trying to detect the object. So it's very simple because we have inbuilt model available. So this can identify certain objects. If you have a requirement of identifying a specific object, let's say for example car or dogs or any other thing, you may have to create your data set. So it depends on what kind of predictions or what kind of object detection you are making, depending on which you can create a data set, and then you can create a code for making the predictions. Right. Okay, now let's understand some of the TensorFlow.js limitations, because as we know that TensorFlow.js is running in the browser and it has certain limitations. So what we are going to do over here is, let's understand it one by one. So one is that the limited computing power. Now, okay, why we say limited computing power is because as we know that, and as we have seen in the earlier slide, that TensorFlow.js works offline, it works in the browsers. So it depends on the capacity of your browser, like the memory of your system, the cache, and everything of your browser. So it has limited capacity. Just like the classic machine learning applications, which runs on the TPUs and GPUs with enormous availability of RAM and the computing power and virtual CPUs and GPUs and a lot of stuff, TensorFlow.js don't have that kind of advantage. So there is a limitation that by using the TensorFlow.js, you have the limited computing power. What all things you can do in the browser, that's it. You can do not more than that, not less than that. Limitations of data. Of course, because the application is running in the browser, you cannot import data in, let's say, GBs. Because when you see the classic machine learning examples or classic deep learning and neural network and what all that kind of thing we do with the Python, we have data set ranging in the GBs or sometimes in TBs. That kind of data set will not be possible to load in the TensorFlow.js because it's running in the browser and browser has certain limitations. So you cannot run a lot of things over here. So limitations of data is one thing, but on the contrary, as we have seen in the earlier slide, that TensorFlow.js gives you facility to make your data private. Your application is running in the browser, and when you are detached from the network, your data is very, very secure. Nobody can access your data, right? So in a way, it gives you an option for protecting your data, but at the same time, you have the limitations of the data in terms of size. Next we have is single-threaded environment. So as we know that when we are downloading any JavaScript, it is an asynchronous operation. It's an synchronous operation. So when that particular JavaScript is not downloaded, recently I was facing the issue when I started my presentation that uh, due to some reason, my TensorFlow.js minified library was not downloaded from the CDN. So it keep on waiting, keep on loading, and till the time that library was not downloaded, it didn't start my training. So that's the problem. But however, by using by using the latest JavaScript framework and latest JavaScript features, you can make it asynchronous and you can improve that. But single-threaded environment can be a limitation for the TensorFlow.js applications if you are loading lots of JS libraries and everything. And the last one is the hardware acceleration. Sometimes it's possible that due to limitations, for example, in Android and iOS, they have limited use of hardware when you are running any application in the browser. So that's where you have limitation. If you don't have support of hardware acceleration, you may not be able to use that particular hardware. However, it's not a problem with almost all the hardwares, but yeah, there is an issue of the hardware acceleration. So this is some of the TensorFlow.js limitations. All right, yeah, so that's it from my side. Thank you everyone for watching this session, and I hope now you understand what is TensorFlow.js, how you can do machine learning libraries, and I'm going to share the code what I was not able to show and some of the code what I have shown with the GitHub, and you can check that code and you can start making the model. This is my Twitter handle, @jdave. I usually put a lot of updates on the technologies and the events and so many things on my Twitter. So if you can follow me over there, you can get in touch with me. If you have any questions on TensorFlow.js as well, at any given point of time, you can connect with me, and I'll be happy to assist you. So yeah, thank you everyone. That's it from my side.
Thank you, Hiren. Thank you, Hiren, for the wonderful session. Do you want to take a few questions?
Yeah, sure, you can take. Yeah, sure.
So Vasudev asks, why can't we leverage GPU on browser while using TF.js?
Okay, so as I have mentioned that hardware acceleration is sometimes not available with the browser, and that's why you cannot, but yeah, you can use GPU with the WebGL. So if you are using, if you are creating any media-centric application, and if you are using WebGL with the TensorFlow.js, you can definitely leverage the power of GPU, but not that particular power which you get when you are running any Python applications, right? So yeah, but still, you can leverage the GPU through WebGL into TensorFlow.js.
Thanks, Hiren, for the answer. Next question is from Gijo. Does running TensorFlow.js in browser can cause the browser to crash?
I would say it depends what kind of operations you are doing. So as I mentioned that if you have doing a lot of operations, you have heavy data, and your browser memory or browser cache is not capable of handling that, it may crash your browser. So it depends on all things, that what kind of data you are using, what kind of operations you are doing, and what kind of model you are running or making the training. It depends on your epochs and lot of other stuff. But yeah, there's a possibility it can crash. However, I would not say that, because nowadays most of the systems are very powerful, like 8 GB and 16 GB and 32 GB of RAM. So I personally I haven't crashed my browser till yet while working with TensorFlow.js, but there is a possibility. So you got to be careful.
Cool. I mean, even most of the capable systems can crash provided the correct settings. Right? So
yes, quite possible.
Beforehand.
Yeah.
So I'll take one final question from Vasudev again. So he asks, is TensorFlow.js compatible with all the standard ML models, or are there some caveats?
Okay, so as far as I have used the TensorFlow.js, all the models, like if you want to do a linear regressions or logistic regressions, all that are available. In fact, you can do deep learning with the TensorFlow.js. You can do the neural network with TensorFlow.js and all sort of stuff. So all these ML models which we normally create in the Python, we can definitely create in the TensorFlow.js. I'm not sure if something is missing, but I need to check that. So yeah, but as far as I have worked with TensorFlow.js, most of the ML models are there. Yeah.
Okay. Thanks for sharing that knowledge with us, Hiren. So I fear I need to cut the Q&A session here
No
in the
worries.
interest
Yeah.
of time.
Yeah.
But for
Yeah.
folks that are asking questions on TensorFlow.js, keep them coming. Keep all of your burning questions on TensorFlow.js coming, and redirect them to Hiren over his Twitter handle. I'm sure Hiren would be happy to answer those questions for you. So
Definitely.
with that, I'll hand it off to Nivu, and I'll see you guys in some time.
Thank you, everyone. Bye.
Hey, Nivu again. Thank you for the awesome session hiring. So next we will, before going for the last talk for today, we have a project showcase, a fitness counter by Ashwin and team. So a small intro about the project. So the objective of this application is to allow a user to focus on the posture. So you can track your movements through the camera, right? And it uses the post distribution model in the backend, and it has a lot of highlights like a squat repetition counter and push-up repetition counter and all, right? So with that, over to Ashwin. You can share your screen and present your project.
Hey, I'm visible, yeah?
You are. You can continue.
Cool. So, hey everyone, my name is Ashwin, and I've been working for a year now as a software engineer. Now, in my final year of college, I had participated in the Google Summer of Code 2019 and learned that the true effect or the true crux of open source software. And my basic motivation is to build solutions that solve everyday problems and make our lives easier. And what other platform to build it than on mobile, which has lately become a human extension. So I personally love how easy it is to experiment with TensorFlow and predict with state-of-the-art models.
So, hey everyone, my name is Aditya. I just graduated a couple of months ago. I come from a small town called Mahu, near the cleanest city of India. I've been a Microsoft student partner in the final year of my college, and which gave me a great opportunity to learn and tinker with new technologies and spread the knowledge among my colleagues. I love contributing to the open source, and I've been working with TensorFlow and Flutter since the past 1 year. I dream to combine these two technologies so that developers like me and Ashwin can build cross-platform apps with edge intelligence more easily. So let's move ahead.
So first of all, I'd like to thank the whole organizing committee for basically providing us with a stage for like our tinkerings with technology. Thank you. And let's get right to it. So the main motivation behind the project was literally motivation. Like things have changed and working from home can sure feel comfortable, but it's the toxic kind of complacency. So losing boundaries between your rest and work, over exhausting focus thresholds, and obviously piling on to the list of extensively increasing to-dos. Now, what works for me currently is the Pomodoro's technique. So for those who haven't heard of it, it's a concept where you focus for 20 to 30 minutes of intense work and followed by 5 to 10 minutes of break. But generally they're walks, but those breaks are never followed. They're always extended. So what I generally do is instead of taking walks, I do something intensive like push-ups or squats, basically body weight exercises to increase my blood flow and focus for the next burst. And I call them micro workouts, and they have definitely become my new normal. So you might be wondering what the project is all about, and so let's get right through the demo. So right now we have only body weight exercises, namely push-ups and squats. I'm not sure if you can listen to it, but basically you can hear a voice counting and a posture correctness message as well as you're halfway through the workout. Now, to ensure proper posture correctness and foolproof counting so that it doesn't get counted when you're moving, we have to be at the correct distance from the camera. Now, this enables hands-free workout counting as well as feedback on your repetitions and your sets. Now moving on to the push-ups demo with this similar concept. So also you might have noticed that there's a lag between the key points and the image frames. And this is solely a Fluttered issue which we stumbled upon, and we'll shed some light on it over the next screens. So regarding the implementation, the interpretation workflow basically begins with a real-time camera feed which generates an image stream, and that is fed into a TF Lite interpreter, and it predicts the 17 key points of the PoseNet model. Now, these key points are then fed into a counter algorithm, which feeds it into a map and maintains the frame-by-frame state of the desired key points, which in our current implementation are just the two shoulders and the two knees. Now, the project was built on Flutter and TF Lite within a single day because we wanted to prototype it much more faster. So basically what we do is we track 4 key points, as I mentioned, the two shoulders and the knees. And as the shoulder traverses through the upper range and reaches the ideal position between the two ranges, we sound the motivational message. And when the user crosses the upper range again while going up is when the counter increments and indicating that the rep has been successful. Now the posture correctness for both the exercises is fairly mechanical. If you can see the two green arrows here, so they are the two ranges that we have found out through multiple iterations of multiple bodies and their specific distances from the cameras, and have found out this to be the median range. So it works for pretty much everyone we have tried it out with. And but obviously these are offsets, and we knew that we could do better, and so we started experimenting with classifying the key points to achieve better poster accuracy. Now more on this from Aditya.
Yeah, thanks, Ashwin. That was a great explanation. So let's move on to the challenges we faced while building Fitness Counter. Firstly, there is no official Flutter plugin by TensorFlow community. Thus, we had to learn and write a lot of native code on Android. Next, the Flutter camera plugin is still under development. So unlike native camera API, you cannot directly get the byte buffer or byte array data from the current camera plugin in Flutter, which makes it a bit slower and laggish, as you saw in the demo. Since the limited support for the operators in TF Lite, implementing a custom model in TF Core and then converting it into TF Lite is still quite challenging. So to overcome these problems, we are working on a Flutter plugin, which is in fact still under development, which allows users to run camera on a background thread and PoseNet on the GPU and generate results at a higher FPS. So let's have a look at the quick demo. So as you can see, it's more smooth. It's running faster than the previous demo. So previously, the time to inference was around 100 milliseconds. That is approx 10 FPS. But we were able to run this PoseNet model on GPU and bump up the time to inference to around 40 milliseconds. That is approx 25 FPS. So now that's a huge improvement thanks to the GPU support in TF Lite. Let's move on to the next slide. Yeah. So what does the future holds? Let's have a look at the big picture. So currently, we are working on improving the user experience of the current version of the app. This would mean a much more smoother experience, a higher frame rate on variety of devices, including a GPU support. We also plan to add support for tracking more complex body postures, body movements, and exercises in the immediate pipeline. As I mentioned earlier, we are working on a Flutter plugin, which will help developers like us to directly integrate PoseNet running on GPU in their Flutter applications. We've also planned to work on involving deep learning approaches in the counter tracking algorithm to make it more accurate. Apart from these, we are planning to add more features like reminders and notification service, more variety of exercises, metric display, including calories and active streak, customized video tutorials for the users, and a social network to make our users feel more like gym at home. So that's all.
So you can contribute if you feel like contributing and are motivated by our presentation, and also connect with us on our Twitter and GitHub handles. So if you feel, if you find it lazy to type, you can always scan the QR code. And the project on GitHub is called Fitness Counter. And most importantly, thanks a lot everyone for hearing us out and bearing with us. Thank you.
Thank you so much for providing us this amazing opportunity. Thank you.
That was a pretty amazing project actually. It was very cool, very cool. Great work, folks. Great work. Okay, we have our final speaker for the day. Her name is Margaret. Margaret is a Google developer expert in machine learning. She is also a machine learning engineer interested in applying machine learning to real world problems. She is especially interested in applying machine learning in the area of art and design. I have had the unique opportunity of working with Margaret on a couple of few projects, and I got to learn from her so much, so much. Besides all of her machine learning engineering work, she also leads GDG Seattle. She is highly passionate about community building and sharing her knowledge with open source projects. So I'll keep it here only, and without any further ado, I'll hand it off to Margaret. Margaret, why don't you take it away? Margaret, you are muted.
All right. Can you hear me now? Yes, great. So hello, everyone. I'm very excited to talk about AI for art and design today. In particular, how we can use TensorFlow Lite to help in this area. First, I will go over how we can use AI for art and design in general, focus on computer vision tasks, in particular generative art and design. Then I will share with you some popular data sets of artist artworks and UI assets. After a brief overview of TensorFlow Lite, I will share about some sample apps and tutorials created by me and the community that can help to assist and inspire artists and designers. So here's an overview of the typical computer vision tasks progressing in complexity. We can use image classification to classify a art style or artist. We can also do multi-label classification to identify movie poster genre. And we can extract the latent features of images and perform visual search and image clustering, for example, find fashion similar to an input image. And we can use object detection to locate all the UI elements in a UI design and use segmentation to segment out the UI elements. And finally, the generative models, which can be used to generate new images, enhance resolution, and perform image-to-image translation. And the more examples on this later. So now I like to go into examples of generative art and design. And Deep Dream in 2015 was an experiment that visualized the patterns learned by a neural network. Similar to when a child watches clouds and tries to interpret random shapes, Deep Dream overinterprets and enhances the patterns it sees in the image. This was perhaps one of the earliest examples of using AI to create art. Then in 2015, we had image style transfer using CNN feature extraction to apply the style of a style image to a contact image and produce a combined image. So here is an example of a developer wrote the details of It's called the Neural Style Transfer 50 Shades of Meow. And the developer created these images with style transfer, and it looks pretty good. So in 2014, we had generative adversarial networks. So what are GANs? GANs, the simplest form of GANs, have at least two networks competing against each other, like in a chess game. And through that competition, and we can create, as I mentioned earlier, like synthesize new images, enhance image resolution, and image-to-image translation. There were lots of GAN variations. I list some of the links to the paper here. GANs are very fun, but it's also difficult to train. So in 2016, we had pix-to-pix. And as you can see here, it can convert like from a sketch to a photo, day to night, black and white to color, etc. The training data sets must be paired. It's a type of conditional GAN. I have included a link to the TensorFlow tutorial for you to look at the pix-to-pix. Then in 2017, we had CycleGAN. What the factor is very similar to pix-to-pix. However, the training data sets don't need to be paired. And as you can see, the examples of horses and zebra, winter to summer, and then you can input like a regular photo containing to an artistic style of Monet or Van Gogh painting. I have included a link to the TensorFlow tutorial on CycleGAN. I think recently one of our MLGDs also created a Keras tutorial on CycleGAN as well. So in 2018, Google researchers experimented with Big GAN, which is a large-scale GAN that generates high-fidelity class conditional images. I have included a link to the paper, and as well as several of the models here on TensorFlow Hub, where you can also find a collab that you can play with. Then in 2018, we had style GAN. So one of the main challenges with GANs is that you don't have a whole lot of control over the images that get generated. And this style GAN will allow you to have more fine control of the images. Like, for example, to generate these faces, you can control, the pose, face shape, age, gender, hair color, etc., etc. Now, I want to switch gear and talk about some other examples. For example, Microsoft Sketch to Code allow you to whiteboard sketches, and then we'll turn these sketches into a actual UI, final UI mockup over here. So how that works is actually use object detection to detect these UI elements and then turn them into the HTML elements and then actually generate that UI. In 2019, Facebook AI came up with Fashion++ that is capable of recommending fashion changes. As I mentioned earlier, a lot of these generative design will do like generating new images, enhanced resolution, or image-to-image translation. But this is a bit different where the model is actually capable of recommending fashion changes. So in a way, it feels like smarter than some of the other models. So now I talked about all these examples and the models. I want to switch gear to talk a bit about data sets. When I try to work on, using machine learning for art and design, I realized that there are a lot of pictures that are like photos. There's a lot of photos, but there's actually not a whole lot of data sets for art and not a whole lot of data sets for design in particular. So I have included the link here for you. The Art Institute of Chicago has 5,000 high-res images. So you should check it out. Like, for example, if you want to use GANs to generate new images, you can look at these data sets as examples for generating them. And I have also included the best artworks of all times. And here they are the artworks by like 50 best artists. And then there's art images, and these have drawings and paintings, sculptures, engravings. You know, when we talk about art comes in all kinds of forms. It can be drawing, painting, sculpture, engraving. It can be photos, you know, just different forms. So this data set has these different forms here. And I have included this one, the Overwatch hero recognition here. I got this data set from the style transfer example, creating the cat style transfer. That author included links to Overwatch heroes recognition data sets. So sometimes when you try to do like a neural style transfer, you might be wondering, you know, what kind of style images to choose. So you want to choose like really vibrant color images for the style transfer. I have also included some Chinese fine art here. And so this is one of the examples of the Chinese art. And then finally, the Museum of the Modern Art collection also has a lot of good images. And for UI and the UX design, I included this Rico mobile app datasets. You can check it out. The dataset has UI sketches as well as not only the UI design, but also like the annotation for object detection as well as segmentation. So, you know, that kind of data for UI and UX design is kind of hard to come by. And as you look at this particular data set, you can also read their research paper to see some of the problems that they try to solve of automatically like generating UI designs. And this two are the common mobile web app icons, and icons 50 are icon data. So you can check it out. I have included some examples here. And one thing I forgot to mention here is also the Noun project that also has a lot of great icons. Not only you can use it for, say, your machine learning training, if you're preparing a presentation, it's also very good for you to, you know, use the icons for your presentations and artwork. So now I want to switch gear and talk about TensorFlow Lite. So what is TensorFlow Lite? When people think about TensorFlow Lite, I know there's a bunch of TensorFlow Lite talk before this, but I still want to mention that a lot of times people think about TensorFlow Lite, they will think about the model format, .TF Lite model, or they will think about the converter, because that's a lot of times many people will work with. In fact, TensorFlow Lite is a framework with a set of tools for deploying machine learning models for mobile and embedded. So it has these four components: the converter that you use to do the model conversion to the .TF Lite format, and the interpreter. So here, the interpreter, you can say, once you create a TF Lite model, you can run that TF interpreter in Python, Python script or Jupyter Notebook or Colab Notebook, to validate that your model is working as intended after the conversion. And when we deploy the model to mobile devices, we also use that interpreter actually to run the inference, to perform a task. And also it has the ops and kernels, and also interface to hardware acceleration here. And it has a bunch of many other tools, which I will talk about later. Like, for example, the model maker, the ML model binding in Android Studio, you know, benchmarking, monitoring, etc., etc. So why should we perform machine learning inference on device? I am sure you've heard about people talking about on-device machine learning, talking about privacy, talking about speed, etc. Well, not all models need to run on device. However, speaking about art and design perspective, we want to emphasize for art and design, it's all about that camera, because a lot of the tasks, as I mentioned earlier, the computer vision tasks, they all require an image as the input. So how do we make a TensorFlow Lite app? So first you will train a model or find a model, then you convert to a TF Lite model format, then you run the inference in Python, and then you can run the benchmark optionally to just get an idea of how the TensorFlow Lite model would perform on your mobile devices. And you can add the model metadata, which enables easier model import into into your project code via Android Studio. I think before my talk, I heard about some snippets of the demo. People were talking about how it's hard to do machine learning on Android. So using the model metadata, it makes things much easier, which I will talk about later on as well in other examples. And once you are on Android, you have these TensorFlow Lite models with metadata. To build the Android application, well, some of the things is standard that you build the UI, right? You think about the navigation, how you go from one screen to another one. And then another thing you have to think about is the input image. As I mentioned earlier, when I talk about it's all about the camera, it's that image that you capture, right? It can be a still image or it can be a live frame. You can also get the image from gallery, pick an image. And a lot of times when I try to do, when I get a TensorFlow Lite model, I want to quickly validate that the model actually does do some, do the inference and give me some valid input. I will try to just put an image into the assets or the drawable folder, which is a very quick way of just giving the input image and run the model through and then see the results without having to worry about building out the UI or selecting from the camera or selecting from the gallery or take a photo from camera. And then you run the model inference and then display result in the UI. So, this is in a nutshell, these are the steps of how to make a TensorFlow Lite app on Android. So on iOS, it might be slightly different, but I suspect that a lot of the steps are similar as well. And TensorFlow Lite runs on different mobile and IoT platforms. So what is a machine learning model? This is for the sake of the people. I don't know if in the audience, if anybody who's an artist or designer in the audience. So when I think of the machine learning model, when I think of model, this is what comes to mind here, a model with a fashion design model. But in reality, the machine learning model is a complex mathematical function after you do the training. And it's a representation of learnings from training data. So in some ways, it feels, like a black box with some sort of magic there. And when we talk about the on-device machine learning, a lot of times we are also talking about the inference on device using that model that got trained to perform a particular task. So how do we get a machine learning model? You can train your own model. I mentioned earlier those computer vision tasks, you can try train those models, some of which can be very challenging, right? Especially when you get in the GANs networks. You can try use transfer learning over here. Basically, you can take a pre-trained model. You can either use that as a feature extractor, or you can use it to continue your training, make it more specific to your data set and the problem that you are trying to solve. Or you can try download the models from TensorFlow Hub, or you can use MLKit. So I don't have a dedicated slide about TensorFlow Hub, but if you go to TensorFlow Hub on the website, you can search for images and text, and you can search for based on the problem that you're trying to solve. And you can also filter on like the version of, TensorFlow 1 or 2, or the format of the model could be a regular TensorFlow saved model format, or JS, TF.js, or TF Lite model format. And I will talk about MLKit later. So one thing I want to mention is the, now that I'm talking about how to make apps or good apps from TensorFlow Lite on mobile, is I want to talk about the People Plus AI guidebook. We're not just talking about technology and tools that's available here. And we're talking about this excellent guide that Google provided on how to design human-centered AI products. I had the honor of reviewing the handbook before it was launched last year. So for example, you can, this is basically define the requirements of your user needs and success, and how you do the data collection, your mental model, how you introduce the user to the AI system, and the explainability and trust, and then get the feedback and control mechanism to improve that user experience. And importantly, how do you gracefully handle failures and errors? And especially when you run the ML models, say, on device, and a lot of times you have to be concerned about the speed and or some sort of error, or maybe the model is not working as intended, right? So how do you gracefully handle all those failures? And before I move on to the next slide, I also want to add a bit of my take on, we come up with the technology first, then solve the problem? Or do we identify the business problem first and then see how we can use technology to solve a problem? So in my view, it's both. Like, we can't just do one or another. We can't just solely focus on the technology and the tools and try to come up with that cool tech and say, oh, what can we do to solve the problem? On the other hand, we cannot also just look at the existing problems and then solve the problem with the tools. We have to sometimes think out of the box, and with the new technology comes, we can come up with a new workflow with the technology. So now I am going to move to talking about apps and tutorials with TensorFlow Lite for AI and art design. So first, I am going to talk about MLKit digital ink recognition. I don't have a dedicated slide for MLKit, but I just want to talk about what it is, MLKit. I talked about you can train your model or download your model. The fact is that it is still very difficult for a lot of developers. If your day job is doing Android and iOS development, you have no idea about what machine learning is. And MLKit is perfect for you because it brings that expertise of Google's machine learning to the hands of developers without really understanding all the nitty-gritty of machine learning. And this particular example, digital ink recognition, is a very recent announcement about, you can read about the blog post here. I have included a link to the sample app for you to take a look. And it can do more than just emoji. So I put an example here. You can draw a face, and then the model will identify, okay, that is a crying face emoji here. So earlier I talked about how you can input an image with selecting from gallery, taking a photo, a live stream, a video from camera. You can put images in assets and drawables. So here, there's one more form of input, image input. On Android, is actually directly use Canvas using a custom view to track the movement of your finger, and then create a bitmap out of that as a input to your machine learning model. So TensorFlow Lite Model Maker is also another way to make the life of mobile developers easier. And currently, the model maker supports image and a text classification. I wrote a 2-part tutorial. The first part is how to run a Jupyter notebook with just a few lines of code. You have these folders of images. In your script, you point to the folders of your input images, and literally just a few lines of code, you can come up with an image classifier. In this case, I used the icons 50 dataset that I mentioned earlier when I was talking about datasets. And then part 2, I talked about how to implement this machine learning model on Android very easily. Again, like you go through the menu path and point to your TensorFlow Lite model, and a class gets generated. You don't have to write the tedious code of trying to load the model, trying to do the pre-processing and run the inference and the post-processing. You don't have to worry about all of that. And one thing I do want to mention about is that when you use the TensorFlow Lite Model Maker, the metadata gets created automatically in the process already. And here's another example on style transfer, and it's on the Google Arts and Culture app that you can take a look here. And it's really fun. This app has more than just the style transfer. It also has other fun experiments you can look at, and also images and anything related to art you can look at. Now, I want to talk about a project called the Selfie to Anime that I collaborated with Sanyak and Khan on this project. It was really fun. And it uses the state-of-the-art paper and unsupervised image-to-image translation, although the code was written in TensorFlow 1. And you use the unpaired selfie to animate images. Remember earlier I talked about how you can have paired and unpaired images. So unpaired images are much easier to come by. And we use the checkpoints and then do the model saving, conversion, run the inference, add metadata, etc., as the steps I mentioned earlier. And I just want to say big thanks to Sanyak on this, also Khan. It has been really great to collaborate with Sanyak and Khan on this one. Really fun project. You can read about the blog post here. Now, this one is a new one called the White Box Cartoon Gun. This one has a bunch of similarity to the Selfie to Anime project. However, with this one, the model's smaller and faster, and it's not just for selfies. For this one, the model only works on selfie images, right? And only on faces. In fact, the model works mostly just good with female faces, with a bit of a bias in the data and the model. With this one, it works on not only the faces, female faces, male faces, and here's my cat yawning. And I have taken some other screenshots, flowers and landscape, etc., etc. I will add the link to the project repo and also the TensorFlow Hub models that Sanya created, including metadata there. And we wrote a blog post together, which is going to be published on the official TensorFlow blog post on Monday. So very, very exciting. Again, great collaboration with Sanyak and Khan. So this one is another example, not yet implemented on Android, but we have the TensorFlow Lite models, and Khan created the TF Lite inference in Python, and we need to implement it. So here's a fun example. You have a original image, you segment the person, and then the background, you take out the background, you mask out the image, and then you blend the styled image. So you basically apply the style to the background, which is very nice, because a lot of times when we talk about the neural style transfer, you have an image, you kind of apply that style. It's fun, but the image itself sometimes doesn't look as good, and you don't quite know what to do with that styled image, right? Unlike this one, you actually come up with the art form of the image. But with this scenario, you have the background as styled image, and the foreground is the actual portrait of a person. It makes the whole thing, very not only artistic, and you can also perhaps print it out and frame it, and put it in a frame and put it on your wall. So very nice example. So now I want to spend a few minutes on community and resources before I wrap up. Sanyak and I and Khan and George, and we have this mobile ML working group, including ML GDEs, TensorFlow User Group organizers, Android GDEs, etc., etc., and also the larger community. We have this repo called end-to-end TF Lite tutorials. We have a lot of other examples completed as well as in progress, and we will love everybody. We will love everybody's participation. And also the awesome TensorFlow Lite. Some previous talks might have already mentioned this. And thanks to the MLGDs and Android community support of the TensorFlow Lite team, I have put together this repo with all the TensorFlow Lite models, apps, tutorials, and learning resources. So check it out. I want to also share with you a couple of other resources beyond TensorFlow. When we think about AI for art, like resources, the first thing come to my mind is Magenta. It is an open source research project, uses ML to make music and art, and you can find various project demo and code on the website. And here's also a website called Artisan and Machine Intelligence, and you can read about all the different blog posts and examples of how Google bring artists and engineers together to create these fun projects, use machine intelligence. And the last one is AI and the future of UX. So if you are a designer, you want to know how AI will impact and shape the future of UX, and go to this website, and lots of fun blog posts on this topic. I'd like to wrap up my talk with my final thought. We live in very exciting times. If you are an artist or designer, AI can help assist and inspire you. And everyone can now make art and design thanks to AI and TensorFlow Lite tools. Thanks everyone for attending my talk today. Please follow me on Twitter, Medium, or GitHub to learn more about deep learning, TensorFlow, on-device, machine learning, and AI for art and design.
Thank you for the wonderful session, Margaret. So if you'd like would you like to take a couple of questions from the community?
Sure. Yeah.
So the first and foremost question I observed was, what tool were you using in order to highlight your slides?
Oh, I have to send you the link. I think it's called the Spotlight. It's a very expensive remote controller, so that when I press a button, it will highlight the slide. So yeah, it's not just software; it's actually the hardware.
I see. I see. So the next question, it's a personal question. So it's a question from me. So you mentioned the guide by pair. So in your machine learning project experiences, in which part of the pipeline would you incorporate pair? Would you incorporate the handbook by pair in a specific step, or would you refer to it throughout the development of your project?
I would say this is really throughout the project, because when you talk about the user needs and success and data collection and mental model, these are pretty much in the sort of a planning stage, for your model, right? But when you talk about explainability and trust, that's also throughout the whole pipeline. And when you talk about the feedback and control, that's more of like, you already implemented your application. You want that feedback loop, because application development design is not a one-time deal. It's not like, oh, I'm done with that application in production, goodbye. It's like you have to continuously improve your user experience. You will also continue to collect data and see how you will improve your model. And then finally, the errors and the graceful failure. This is both in your design as well as implementation of your application.
Fair enough. That really makes sense. So the second last question is from Korean. He asks, what is the future of AI with art going to impact artists? Is it just for inspiration purpose, or does it hamper their creativity purpose as well?
I am not entirely sure about the hamper creativity part. In fact, a lot of times when we talk about AI, automation is a big aspect, automating the workflow. Like, for example, we take a picture, click a button, you can already come out as anime or cartoon, right? Which, as an artist, it will take me a long time to draw a picture, for hours or days, right? So that automation part, people actually will think about job loss, or the AI taking over. I will say, like any kind of technology, for example, when printing comes along, when cameras actually were invented, and people will worry about, okay, you can take pictures now, we don't need artists anymore to draw and paint, right? But that is not true, because with new technology, you come up with new form of art. And I think the inspiration is a very big part of a creative process. And I firmly believe that AI will help with that. I do not think it would hamper the process. Although, if you talk about like modifying the current workflow, perhaps it will.
Yeah, so that's my belief too. It's not gonna replace or it's not gonna hamper. It's more like it will aid the artists in coming up with new workflows. I mean, that's what my thought is too. So the final question from the community is, will they be getting your deck? Will you be sharing your deck?
Yes, absolutely. I will share my slides.
So should they be following your Twitter to get the slides?
Exactly. I will put my deck on Twitter. Yes, please follow me on Twitter.
Cool. So I hope, folks, you got your answers, because this was probably the most asked question. So Margaret, once again, on behalf of the entire team of TFUG India Summit, I would like to thank you. Thank you very much for spending your time with us, for delivering an excellent session on the entire landscape of art and design with the focus on TensorFlow Lite. I really appreciate it, and I hope to really having you soon in one of our sessions.
Great. Thank you so much, Tanyak. And thank you for inviting me, and thanks to the organizers.
Of course. Thank you. Okay. With this, folks, I'm gonna hand it over to Nivu. And don't worry, we are not gonna be taking more than 3 minutes, I guess. Nivu has something exciting to share with you folks. And with that, we'll be concluding. So over to you.
Hi, I'm back. So that's it for day 2. And I think today we had an awesome session on TFR Mobile by Khan, Coral Embedded Platform by Naveen, TensorFlow.js on browser by Hiren, and A&R by Margaret. All these things are cool and exciting. And a big thanks to the speakers for being a part of TFUG India Summit and sharing their knowledge. I thank them on behalf of the TFUG India team. And thanks to the audience. This event is for you and because of you. And thanks for staying for the entire session and keeping it active in the chat and on the social media as well. This video will stay on YouTube. You can rewatch it anytime. For reference, you can come back again and watch it. You can share it with your friends and please make use of it. And another thing is, don't forget to fill out the feedback forms. You will get a cool certificate with your name on it. Okay. So hope you can see the link rolling down below. So please fill out the feedback form. So it will be really helpful for us to know how the event went and also improvise for the upcoming days. And once you get the certificate, feel free to share it on your social media platforms, tweet us, Instagram, and share it to your groups, and please tag us. And also don't forget to join your nearest TFUGs. So we are active on 13 cities. Please join as soon as possible. And that's it for today. And also I have another thing. Tomorrow is on TensorFlow for production. So please do join the session. We have exciting lines of speaker sharing their knowledge from few are Googlers and few are outsiders. And ask more questions. We have exciting gifts for the best questions for tomorrow. And take care. See you tomorrow. Bye.